walk and they decide to estimate the height of a local tower. They have no measuring tape, so they use one of Gary's shoes. They measure the tower's shadow and find that it's 30 shoe lengths long. They measure Rosie's shadow and find she's 4 shoe lengths long. Rosie knows she's 140 centimeters tall. Uses information to estimate the height of the tower. Now, something I want to talk to you about is basically shadows in general. Like, so if you imagine the sun is up here, okay, and it's shining down at the same angle, okay. So if you have a tower, and let's say a tower, for example, the height of the tower and the shadows will be in proportion to each other, okay. So that's the first thing we got to accept there. So you imagine that this is a big tower. The red part represents the tower and the blue part represents the shadow. Let's say, for instance, the shadow is longer than the tower, which can happen, okay. So actually it's usually better to do the tower bigger than the shadow, whichever way we want to do it, to be honest. Here we go this way, okay. So the tower is taller than the shadow in this case, okay. So imagine, for example, the tower was height 200 meters and the shadow was height 40 meters, or sorry, length 40 meters, okay. If we had a smaller object further away, so for example this green line here, and for some reason the tower is, I don't know, this is 50 meters. 50 meters is 1/4 the height of 200 meters. This means that the shadow would be 1/4 of 40, which is 10 meters. Essentially what we're saying is that 50 over 10 is in the same ratio as 200 is to 40. And that's the type of trick we're going to use for question 7. What we're basically going to say is we have our tower here, which we don't know the height of, but we know it has a shoe length of 30 shoe lengths in the shadow, okay. And then we know that the girl Rosie is 140 tall, and we know she has a what's called a shadow size of 4 shoe lengths. So what we can determine here is that what's 30 divided by 4? 30 divided by 4 is 7.5 to my knowledge. So if the shadow is 7.5 times longer, that means the height has to be 7.5 times bigger than Rosie. So it's 140 multiplied by 7.5. 140 multiplied by 7.5 is 1050 centimeters, or 10.5 meters. Okay, so that question wasn't so bad. Question 8, which we have here. We have 2 right-angled triangles. What are they? They are ABC and ACD, and they have a right angles at B and D respectively. AB is 10, AC is 12. So we're going to try and find the angle Y. Here is the angle Y. So we're going to use SOHCAHTOA, silly old Harry, chased our horse through our attic. We're going to find out which function are we using, sin, cos, or tan. Well, we know the hypotenuse is 12 and the adjacent is 10, so that's adjacent and hypotenuse. So we're going to use cos. Cos y equals 10 over 12. Then y on its own has to be cos inverse 10 over 12. Put that into the calculator. Make sure you're in D mode, so shift cos inverse 10 over 12. And you should get an angle of 33.55 or 33.6 to 1 decimal place. Okay, let's go to part 2 then. Find the value of x, give your answer to 2 correct 2 decimal places. So we need to find x. Well, good thing about x is this is an isosceles triangle and it has to obey Pythagoras Theorem. So it's actually going to be 12 squared equals x squared plus x squared. So we can try that out on this page here. 12 squared equals x squared plus x squared. 144 equals 2x squared. X squared equals 72. And square root of 72 is 6 root 2. Otherwise known as 4.485. Be careful with that now. 4.485. That'll round off to 4.485. That will actually round off to 4.49. Or is it 8.89? My fault. Give me a sec. 8.89, my fault. So 8.49. Don't know where I'm going these days. Okay, there you go. Now, part B. Diagram below shows two different triangles, PQR and RSP. The points R, S, and P are on the circle K, and Q is the center of circle K. QPR is 22 degrees as shown. The angle PSR is marked T. Great. So what do we have to do? Find the size of the angle T. Show all your workings. Okay. Let's figure out this. So, angle QRP is 22 degrees. Reason being it's an isosceles triangle. You can never spell isosceles. Okay, this means that if that's 22, the angle PQR, therefore angle PQR has to equal 180 minus 22 minus another 22, which is 136 degrees. Okay, now the reflex angle PQR, basically take it away, so if that's 136, the other one has to be 360, take away 136, which is 224 degrees. Now, what we all know is that this angle here, they're standing on the same arc. If you look at this arc, the large arc P to R, both angles, the angle T is standing on that arc, and the angle, the reflex angle PQR is standing on that arc as well. So that makes T half of 224. So T will equal 112 degrees. Okay. Let's move on to question 9. A statement that is accepted without proof, well, that is an axiom. A statement that follows easily from a previous statement, corollary. An argument showing that a statement must be true is a proof. Okay, so that's good revision on that stuff. Salem writes the following statement: if a shape is a square, then it must have 4 right angles. Complete the converse of complete the following of the converse of Salem's statement. If a shape has 4 right angles, then it must be a square. Then it must be a square. Now we know this is false because rectangles have 4 90-degree angles, and rectangles aren't squares. To be a square, you had to have 4 equal lengths, while rectangles only have 2 pairs of equal lengths. It's false, and the reason why it's false is rectangles has 4 right angles but might not be a square. It's a weird statement. Some rectangles can be squares if you make all 4 lengths the same, but most rectangles aren't squares. Oddly enough, all squares are rectangles, because to be a rectangle you only need 2 pairs of matching sides and 4 90-degree angles. Just to remember that. Okay. Next thing is a proof, but we did that in the proof section, so now I'm going to move on to question 10 instead. So to find the proof of that last question, you need to visit my proofs. It's done there. Okay, let's find out where A, B, and C are. Well, A is the point 2, 1, 2 up, 1 across. B is the point 10 across, 2 up. You see here, 10 up, 2 up. C is 4 across, 5 up. Show that ABC is right angle triangle without measuring. Okay, well, I'd be inclined to use. You can do it this way. You could get the length of B to C, then get the length of A to C. So get the length of B to C, get the length of A to C, and then get the length of A to B, and you could do AB squared. You can prove it by using Pythagoras Theorem. AB squared equals BC squared plus AC squared, and you'd use the distance formula 3 times to first find the distance of AB, then to find the distance of BC, then to find the distance of AC, and then use Pythagoras Theorem to prove that it balances and obeys what's called Pythagoras Theorem. That equals and balances. But look, I don't want to do it that way because that's a lot of work. So here's what I'm going to do instead. I'm going to use slopes. I'm going to prove that AC is perpendicular to BC. That is my plan. Now the great thing about this is I can do rise over run. I can do the slope formula if you want, which is y2 take away y1 over x2 take away x1. We can see you could do the slope formula, no bother there. I'm just going to use rise over run. 2 across, 4 up. I'm going to do rise over run, which is 4 over 2, which is a slope of 2. And for the other one, down 3 across, so what's this one? Down 3 across 6. So down 3 across 6 is a rise of -3 and a run of 6, which is a slope of -1/2. Now to prove that they're perpendicular, we need to write down m1 multiplied by m2 equals, I need to have all this workings down here by the way. So slope BC, and the blue one is slope AC. Okay, now we do m1 by m2. If you multiply your two slopes by each other and they equal -1, then you know that they are perpendicular to each other. So that's the test. So you multiply them by each other, you get -1 equals -1, and then 3 dots, it follows they are perpendicular. And hence right angle triangle. Okay, brilliant. Let's move on. Hence, otherwise show that the area of triangle ABC is 15 square units. Oh, we're going to have to use the area formula anyway. Oh no. All right, so what we can do here is we can do base times height. So it turns out we're going to have to use the distance formula after all. We're going to get the distance of BC and then multiply by the distance of A to C. It's going to be a lot of fun. So get the distance of B to C, then get the distance of A to C, and then that's it. So let's bring my points. So we have to get BC, distance of BC, distance of AC, then do a half base times height to get the size of the triangle. So you go into page 18 of your tables and you look up your formula for distance, or say for distance between 2 points. We're going to get AC, which is going to be the AC is here, and then BC, So a half base times height. Either one of them can be the base and either one of them can be the height. So it's just half the green line multiplied by the blue line, because only because it's right angled. It doesn't work for non-right angled triangles. Now we're going to get BC as well. Okay, so let's start off with AC. Got a x1, y1, x2, y2. So what we're going to get there is 4 take away 2 squared plus 1 take away 5 squared. 2 squared. Enter all that into the calculator. Two root 5, or 4.472. 2 root 5 will be the better way to do this at the moment. 2 root 5. Okay, let's try to see what BC is. So BC, we'll call that one x1 and y1 and call that x2, y2. So it's going to be 4 take away 10 squared plus 5 take away 2 squared. Once again, I got to enter all this in the calculator. So it's going to be 4 take away 10. Hopefully this comes out something a bit nicer. And then, what's it? Oh, sorry guys, in the first one I actually made a slight mistake. It was, it's 5 take away 1, but you still get the same answer, so it's no big deal. So this one should have been 5 take away 2. Always worth checking your answers. Okay, 5 take away 2. I'm hoping for 3 root 5. There we go, 3 root 5. I'll tell you what I was hoping for 3 root 5. Remember, it's a half base times height, which is going to be a half 3 root 5 times 2 root 5. Root 5 by root 5 is 5. 3 times 2 is 6. Half your answer. Half times 6 times 5 is 30. Half of 30, 15. And that's how we knew we had the right answer there, okay? So we knew we were on our way to getting that one correct. Okay, I'm going to pause it. Okay, the point D lies on AB such that CD is perpendicular to AB as shown. No bother. Give your answer in short form. Remember that the area of ABC is 15. So what we're trying to do, we're trying to find CD. Okay, well look, the deal is that it doesn't matter which, the area of the triangle in question is a half base times height. It doesn't matter what base and height you take, provided they're at 90 degrees to each other. So you could take CB as the base, you could take AC as the height, or vice versa, you could take AC as the base and CD and CB as the height. That's because they're at right angles to each other. But however, there's another little way we can do this as well. We could take AB as the base and we could take CD as the height. See it like that? So what we're going to do is we're going to calculate the distance of A to B first. So we're going to use x2 minus x1 squared. Okay, so this is going to be, this is x2, y2, so that should be 10, 2. This one is 2, 1. And this is x1, y1. Okay, and we get 10 take away 2 squared plus 2 take away 1 squared. And we throw all that into the calculator and let's figure out what we have going on here. We get 10 take away 2 squared plus 2 take away 1 squared, and we get root 65. Okay, so that is root 65. So a half root 65 multiplied by this height for CD equals 15. So we can say is a half root 65 multiplied by H or CD equals 15. So division of 2 on the right is multiplication of 2 on the left, so it's 15 multiplied by 2 is 30. Root 65 is multiply on the left, which makes a division on the right. Now I'm just going to enter into my calculator 30 divided by root 65, hoping something will come out of it. 6 root 65, what's that one? 6 root 65 over 13. Yep, that is in fact your answer, as confirmed by the marking scheme. So I'll go there, guys. Okay, so that's that question done. Next one, we have a couple of lines and we got to match up the equation with the line. Now there's a formula which is called y equals mx plus c. Okay, so the deal is what y equals mx plus c. If I was to write a formula of, let's say, 3x plus 6, what this means is that it'll cross the axis at 6 and it goes 1 across 3 up every time. So it's quite a steep slope, like so. So this line would be coming in something like this, very steep. Now if I was to change that to, let's say, let's go to minus 6 instead, that's the last number. So if I was to change that to minus 6, I'd be all the way down here at 0, minus 6. And once again, I'd still be going straight up with 1 across 3 up. So I still have a very steep slope because I have a slope of a positive 3. Now, if I was to set up a different type of diagram, like this, if I was to have y equals, for argument's sake, if I was to have y equals minus 2x plus 5, I'd cross at 0, 5, no bother, but my slope would be going 2 down and 1 across. So it'd have quite the negative slope down this way. Okay, so the value of the value before the x can tell you the slope and the intercept, right? So this one has an intercept of plus 3. This one has an intercept of minus 3. This one has an intercept of plus 3. This one has a steeper slope of 2 compared to that one. So these two cross at 3, but Q has the steeper slope, so that must mean it's the slope of 2. That must be R. This one must be minus 3. Because it's, sorry, this one must be T because it's a shallow slope. Now the other one, however, it says R is parallel to T and Q is parallel to S. That means S has to have a slope of 2x, but it crosses at minus 3, so it must be 2x minus 3. Complete the table above to show the equation of each line in the diagram. 3 equations are already filled in. Done. Use algebra to find the point of intersection between the lines y equals x minus 3 and 2x plus 3. Okay, so we're going to use simultaneous equations. What we're going to do is bring the x over this side, so it's going to be minus x plus y equals minus 3. Multiply both sides by minus x minus y equals 3. Then I'm going to bring the 2x to the left here, so I'm going to get minus 2x plus y equals 3. Oddly enough, we're going to keep them the same there because I think they line up quite nicely now for a simultaneous equation. If I add them both together, I'm going to get minus 1x, the y's will cancel and I'll get equals 6. Multiply both sides by minus, I'm going to get x equals minus 6. Okay, next thing I have to do is find out the y value. Well, what we can do here is that we know straight away that x plus y equals minus 3, so I can sub it in here if I want. So I can get minus 6, which we all know is plus 6, plus y equals minus 3. Bring the 6 out the other side. Y equals minus 3 minus 6. Y will therefore be equal to minus 9. So the point in question is minus 6 minus 9. Next question. The line L is a vertical line. It cuts the line y equals x minus 3 at A and the line and the y x plus 3 at point B. Find the distance of A to B. Well, there's an interesting thing about these are parallel lines. Okay, And it doesn't matter where you cut the parallel lines, it's always going to be the same distance in between them, provided you drop vertically. So I'm going to highlight the question we're talking about now. We're talking about R and T, the shallow ones. So the two parallel lines we're talking about are these ones here. See this one here? That red one there, and this red one here. Okay, I'm just going to continue along slightly. Now, what happens is when you drop a perpendicular line, like a green line, it doesn't matter where you drop the perpendicular line, the distance is always the same because they're parallel lines. So I can slide any one of these around and it'll always fit the same distance between the two red points. And that leads me to, if I go to the y-axis, I know one of them is 3 above the y-axis, and I know the other one is 3 below the y-axis, and 2 3's added together must give me a vertical distance of 6. So very easy, that one actually. Okay, done and dusted. Alright guys, I think that's oh, we have a question 12, never mind. I was hoping it was over, but you know, these tests, they seem to go on forever. Now we gotta find the length of this side. Now 60 degrees is looking directly at it, that makes it the opposite. This one here is the hypotenuse, so what we can say is sine 60 degrees equals opposite over hypotenuse, which is x over 10. Then we can say that x equals 10 sine 60. And 10 sine 60 is 5 root 3. Okay, so that's it, 5 root 3 for that. The diagram below shows regular hexagon with sides of length 10 units. The hexagon is divided into 6 equilateral triangles. Great thing about equilateral triangles, lads, is that this means everything here is a 10, no matter what way we look at it. Now, the great thing about isosceles and equilateral triangles is that you can sort of cut them in half. I'll show you what I mean in a second. Yeah, here's an isosceles triangle, okay? So let's say, for argument's sake, this isosceles triangle is 10, 10, and 6. You can drop a perpendicular line straight through the middle and cut that into 3. And then you can find the perpendicular height really quickly. And equilateral triangles are no different. What we can do here is we can design ourselves an equilateral triangle. Hope that's pretty close. That can be 10, that can be 10, that can be 10. Then I drop a 1 straight through. Then we have this is 5. Okay. Next I can find the perpendicular height. So we can say that 10 squared, because how many triangles is there again? There's 1, 2, 3, 4, 5. There's 6 triangles, and if I figure out the size of one triangle, I can just multiply the answer by 6. So I'm going to do Pythagoras Theorem. So I'm going to get 10 squared equals 5 squared plus h squared. Essentially 100 equals 25 plus h squared. 75 equals h squared. And then h equals root 75. Which is 5 root 3. Okay. Now to get the area of this triangle, we can do a half base times height. So 5 root 3 by 10. 10 is the base, and 5 root 3 is the height. Base, height. Okay, so then it's going to be a half 10 times 5 root 3, which is going to be 25 root 3. Okay, then we got to multiply this by 6 to get 150 root 3. And as predicted, the a value is 150 because it's meant to be a natural number. Okay guys, I think that's us over and out now. That's it. That's all for the 2017 paper. Chat to you soon.